Let's see how one can find the solution for the system with a given input. We will do so by means of time domain simulation of our model. We start in MATLAB. First, we want to define the constant used in the model for what we generate a MATLAB script. In the top of the script, one may put information on the file and the help notes. The constants to be defined is the resistance and the inductance. Note that the percentage sign comments out, leaving possibility to noting symbol names or units. The script is run by pushing the Run button in the top menu or hitting F5. If you want to prompt to the command window, you'll leave the semicolon out, as you see here. Note that the constants are now defined and available in the workspace when the script is run. To clear the workspace, use Clear All, and to clear the command prompt, use CLC. Simulink may be opened either from the top menu or by writing Simulink in the command window. We open a blank Simulink model and saves it. Blocks and functions is included in the model either from the Simulink block browser by drag and drop, or by typing the name of the block after a left click in the model canvas. Let's now refer to our model of the electrical motor with the inertia and damper load. We start building the model from the output, which here is the velocity theta dot. The velocity is found by integration of the acceleration. The acceleration comes from Newton's second law, where the torques are multiplied 1 over the inertia. The torque are here the motor torque and the damping torque. The motor torque is the current multiplied the motor constant. The current is output of the integration of the current change. The current change is dependent on the voltage drop in the resistor. The input voltage, which we here set as a step, and lastly the electromotive force. Here we have the model implemented in Simulink. However, let's define the input voltage with time at which the step is given, value before the step, and value after the step. Furthermore, we include a scope to visualize the model output. The last task before running the model is now to define the values for the input step. We jump back to the MATLAB script and define the step time to 2 seconds, start value to 0, and final value to 5 volts. Back in Simulink, we now run the model and see the model output with the scope. Most often we are interested in scoping more states and not just the velocity. We thus expand the scope to 3 inputs and change the layout. Now we can plot the velocity, current, and input voltage. In the scope, you may zoom in on especially interesting areas. The tolerance of your model solution may be changed in the simulation setting.